Good morning. Now I know I'm between you and lunch, so I'll try and be as quick as possible. A little bit about me. It might sound unusual with my accent and German edge cloud. I'm actually Australian and now live in Germany. It's a little bit of an interesting story. In Australia, we were very quick to adopt cloud. And I was selling a lot of enterprise server rooms and data centers. And one day, a couple of years ago, I walked into one of my clients who I built a data center for, was 30 or 40 racks. And they gave me a call and they said, Jason, can you come in? And I thought, fantastic, this is great. I'm going to go in and hopefully they're expanding. And when I walked in, they'd actually had all of the enclosures and racks pushed up into the corner, and they had 2 racks left. And the guy said, Jason, how much can you give me for the rack second-hand? What the hell is going on? What's happened? And then moved to Amazon. And then I went and saw a university, and then moved to Google. And I thought, geez, this is killing me. Like, I'm not going to make another buck here. And this was the start of the cloud centralization cycle that we saw. So I moved to Europe, because, and Germany in particular, because it is the powerhouse of Europe at the moment in terms of data centers and builds and stuff that's going on. And I thought, great, I'll be safe there for a while. And now what happens is edge all of a sudden becomes very, very important. So that centralization that was happening is now moving back to a distributed model. But you know what? It's actually really interesting because it actually opens up new opportunities for something to sell again at this point of the cycle. So if you were in a large vendor or manufacturer, you could sell to the co-location providers, and even in the company which is part of the company I represent, which is German Edge Cloud, which is a startup. It's part of the Freedom Low Group, and it's part of the same company as Rittal. Now Rittal make enclosures, and we make most of the enclosures for the market. So a lot of people may not have heard the name Rittal before, but if you've bought a HP rack, if you've bought a Microsoft rack, if you look at Facebook, they make all of the enclosures. They own pretty much the enclosure market. So when looking at that, they can deal in volumes and sell to co-location and hyperscalers, and it's great. But what happens to the rest of the market? So for me, coming back to a distributed approach and an edge is a great opportunity and one I'm very excited about. What I'm going to talk to you about today is, I'm not going to concentrate too much on Open19 because we've seen a lot of the technologies and the vendors have put a lot of stuff. I actually talk about the project itself and what we're doing with Open19. So German Edge Cloud, we'd probably end up being called European Edge Cloud, in fact, with the amount of response that we've had. But we're a startup, we've literally just launched, we've soft launched at the HMI Fair in Hanover. And we've been involved in this for around 18 months or so, looking at this market. It's really interesting. Germany is a very conservative place. It's full of what I call server huggers. They were very reluctant to go to co-location, and they've been very reluctant to go to cloud. There is cloud usage in Germany, but most of it is still kept in-house. And one of the reasons for this is privacy, and also a conservativeness on European or German product. So they like to use German products. So if you look at Germany and you look at the cars, they will drive German cars. I turned up to Rittal in a Toyota, and I tell you, I heard it for months until I changed over to a Volkswagen. They don't like it. So they're really, really conservative. So people like Amazon and Google and so on, yes, they're in the market, but there's a lot of challenges. And what I'm going to be concentrating on is a part of the Edge Cloud. We're dealing mainly with industry. And I'd like to take you on a little bit of a journey on what we're doing there. So Industry 4.0 actually came out of Germany. It's, for want of a better word, smart factories. And it was interesting when I was hearing some of the other presentations because they were talking about how the internet has to change and how we're delivering content and so on, and I agree with that wholeheartedly. The way that things are moving, especially in smart factories and industry, is almost turning the internet upside down. So as a consumer, you might be streaming data from Netflix or other things, and these are the types of products we put CDNs in for, and there's a lot of use cases around edge for consumption. But when we move to industry, we're actually trying to push data the other way. So when you're dealing with a factory and industry, you're dealing with a lot of sensors, and a lot of times thousands and thousands of sensors, and you're dealing with millions of data points. And what you're actually trying to do is you're trying to do analytics on that. You're trying to do decision making. So what you're trying to do is you're actually trying to push that data up. Now, CDNs don't really help you in that regard. So you really need to have computing as close to where you need to make the decisions as possible. So from German Edge Cloud, this is what we're trying to do. So our use cases are mainly around the Industry 4.0, Industrial 5G. What's also interesting in Germany is they've opened up the private 5G spectrum now. So we see that private 5G is getting a lot of acceptance into, again, factory automation because it works a lot better than Wi-Fi. There's a lot of reasons around that. So we're seeing a lot of private cell 5G getting done in industry. We have quite a bit of what I like to call pilots as opposed to proof of concept that we're dealing with a lot of the industrial automotive manufacturers and people in the supply chain of automotive manufacturers, because obviously Germany has a lot of automotive manufacturers. It's very good. And we're doing a lot of things around machine learning, artificial intelligence, machine learning, and then data sovereignty is extremely important. So in Germany we have something called the Internet, the Information Data Space, where manufacturers, even if they're competing, are actually sharing data across a supply chain. And this is a really interesting concept where the track and trace and sharing of data and data brokerage comes in and can really only be done in a private cloud network. So what we're seeing today, we're seeing a real convergence. You see this in telecoms, and you really see this in the industrial world now. So Industry 4.0 is converging IT and industry. So we used to have a machine, and the way that we interact with that machine is using things like Modbus, program logical controllers, SCADA systems, and so on. And what we are seeing now, very similarly to what I say with telco, is IT is coming in. So program logic control, PLCs, are getting replaced by IT boxes. Because what's actually happening is you have virtualization. So same with what you have in the telco, you have an industry where you may have a lot of PLC controllers are now virtualized and they are in an IT environment. So now we're trying to put IT in an industrial environment. Now, Rittal is very skilled in industrial cabinets and used to this. Now we're seeing the IT cabinet and the industrial cabinet are actually the same thing. They're sitting in the same place, and we're having to deal with some interesting environments to deal with heat and dust and noise and vibration, which generally IT stuff, PLCs were hardened for that. IT was generally in a clean room. So again, there's some interesting challenges there. But we're seeing technologies, how we actually take the information from these machines, and a lot of these are actually coming with network ports on it that support a protocol called OPC UA. And what we're doing is we're taking OPC UA and we're using OPC UA with TSN, which is called time-sensitive networking. And it's really very important when you're trying to do automation. So one of the big gaps that's been in the market is how we actually use TSN to coordinate these machines so we're able to actually make these decisions. So we're working very closely with it's an organization in Germany called the Fraunhofer Group. If anyone's heard of them before, they're a semi-quasi government research establishment. They actually invented MP3. So that's where you may have heard that name before. So we're working very closely with them. They're doing a lot of stuff with industry around the analytics and other points. So we're working very, very closely to get our machine learning and other software. So what are we doing? You know, and there's a difference between sort of edge computing and edge cloud, but essentially, to make it simple, we started off and we were thinking about putting data centers, what we call leaf data centers, whether it be containerized systems, around Germany, and I'll show you how many we were looking at doing. When we started doing the pilot projects, we found that most of the customers were wanting it on premises. So again, with this convergence of what's happening, they wanted it there, but they wanted to consume it like a cloud. So they still wanted all the benefits of cloud, but they wanted the benefits of actually having it on their premises. So again, some really interesting things going on there. We still will do things like leaf data centers around Germany, but the real change is, yes, it's on premises, but now it has a cloud component to it, and it has the right APIs and gateways to come out to other services as well. So whether it be our private cloud or out to things like Amazon and Google and other types of clouds, a lot of the customers are looking to utilize some of the tensor machine learning Google stuff that's going on. So they still want it private, but they want to use some of these APIs as well. So we can do that. So here's a map of Germany, and here's our portfolio. So we have a manufacturing edge machine learning layer with software as a service, platform and infrastructure as a service, manufacturing software layer, and a services layer. So when we actually looked at the market, we found that in order to service Germany, and Germany is really interesting in that you don't have manufacturing hubs in one place. You could drive 2 hours out of Frankfurt through a tiny little village, and there's a massive BASF factory or a massive 3M factory, and it's throughout the whole of Germany. It's very different from what I'm used to. So our goal was, how are we actually going to service Germany, because it is so distributed? And we looked at going, okay, what would be the latency that we needed? So in order to give 1 millisecond latency, so from the edge to a leaf data center, we would need to build around 20 leaf data centers around Germany. When you look at the latency, people say, why are you targeting 1 millisecond? That seems quite fast, when other people were saying, you know, anything below 20 or 10 should be okay. But that was the goal. It was an ambitious goal. Whether we build that, we're still in the phase where we're looking at use cases. As I mentioned, most of these customers have turned around now and said, we want it actually on the premises. So one of the things that we are doing is, with the Fraunhofer Group, is we're actually creating on-premises edge data centers at all the Fraunhofer locations and having a mesh network for the German edge cloud with them, because they're across Germany as well. And then as we build out the edges, then the use cases will come with the leaves. That's what we think anyway, so that's the plan. So why are we doing this? And again, I mentioned the conservativeness of Germany and why they aren't using things like Amazon. Industry is the heartbeat of Germany. Industry and manufacturing is the heartbeat. And they are very uncomfortable with putting manufacturing and factory data into a public cloud. There's a fight on at the moment with the industry of Germany and the US, around the US Cloud Act. So a lot of the companies in Germany, in fact, the manufacturers in Germany, whilst they may use cloud for certain workloads, they will not move their workloads to the public cloud. They see it as a massive risk for Germany. And when you think about manufacturing and how important it is to Germany, I can understand why they are conservative about it. So data sovereignty is extremely important. I mean, things like GDPR and other things that came out is something that you see on the privacy side and so on, which is a little bit different from here. So there is really no European cloud, so to speak. So there was something that came out just recently with the German police with the cameras, and that's going into what's called Bundescloud, which again is a public cloud, and there's a lot of political fighting going on with that. So we see, German Edge Cloud, we see this as a massive opportunity for us. The use cases are extremely valid. It's an edge computing use case, and it's a cloud use case as well. So for us, we see this as a massive opportunity, especially when you combine that with what's happening. As I mentioned, 5G, the private 5G in the factories. A lot of the factories will be deploying private 5G, but that data has to go somewhere and has to be processed somewhere. And again, when you move that to some of the public cloud providers, so some of the public cloud providers will allow you to have private and then allow you to go to the public 5G. But again, how open is that in terms of data and cloud? So we see this as a massive opportunity. So decentralized, smart G usage, and then easy to consume as a cloud-based system. So we are open in terms of what we're using. Open19 is our platform that we are utilizing now. So we're in the pilot phase right now. And someone said it before, we see Open19 very much for edge, and has some really interesting reasons why. But one of the big reasons for me is the simplification of when you have these edges of being able to service. You can't have this like a centralized system where you have a team and smart hands and these types of things. You need a system where you can reduce human error, which for me is, you know, being able to not have to go to the back of the rack anymore. I mean, as a cloud service provider as well, we do cloud service providers, the amount of downtime that we've had has been caused by human error, and has been caused by someone pulling out the wrong power cable or knocking something or doing something. So not being able to get to the back of the racks or having to do that anymore is extremely important. Being able to go in and just swap devices and add things just from the front is, again, very, very good for quickness of deployment and suits itself very well to what we're doing. Again, you don't want to be playing around when you're in a factory type system. You don't want to be going in and playing around some of these machines. So being able to access stuff from the front is extremely important. So one of the pilots I'll mention quickly is we're doing with a company called Limtronik. Is we have an on-premises edge with machine learning, and we have a camera system on the manufacturing supply where the PCB boards run down, and it's a quality of service analytics, real-time analytics. So as the boards are coming down, the camera looks at the PCB boards and is able to recognize errors and able to then take action with the TSN protocol in real time for this manufacturer. So they make a lot of the devices, again, PCB boards for automotive industry. These slides will be available. I won't go into depth into this one on here, but this shows our predictive maintenance analytics and streaming analytics in real time block. Supply chain track and trace is another one of our pilots and use cases we're doing at the moment. if we can see here on this next slide, the industrial data space where you have people like Limtronik and Bosch and other manufacturers providing up to, let's say, a Mercedes or an Audi or Volkswagen. They want to be able to see every single component, where that's come from, what the manufacturing date is across the industrial data space. So the industrial data space is a sharing and brokerage system that allows the sharing of that type of data to the end customer without revealing the privacy and other things of those individual manufacturers. So what we're doing at the moment as well is in our own factory. So Rittal has a new factory in a place called Haiger, and it's about 2 hours north of Frankfurt. And this has been built from scratch as a smart factory, an Industry 4.0 factory. And within that factory, we are doing a pilot now where we place a 40-foot, actually, sorry, it's a 20-foot container, this one, 20-foot container, and that has the Open19. So it has our racks with the Open19 cages in here. And we are doing machine learning from the factory. So we're taking data from the factory, and this factory is making some of our cooling units. And we're taking the information from that and processing it on site. So if you like, I think here in the US you call it drinking the Kool-Aid or taking your own medicine. We are doing that as well. I think that's extremely important. And we've had some really interesting things with Open19. And it's great because it allows me to deal openly, and I think this is the new world of openness, deal with what could be considered in some respects to be competition. So Rittal is a massive enclosure manufacturer, and we would compete. So in years gone by with Flex, for example, we would compete, but now we're working together in this to actually provide a whole solution. I think that's really important as well. And not only that, even on the software side as well, some of the use cases and other developments that are going on will benefit the whole community. And again, we see that when it's open and shared, I think everyone benefits in the long term instead of locking these things up. And that's why I'm really passionate, as I have been from the start, about Open19. Open19 for me really solves a lot of problems where the open compute, I think, was a great thing, and it works very well for hyperscalers. And we do a lot of those systems as Rittal, and the integration that goes on with those. But it works very well for hyperscalers, and there was a gap, I think, when we come. It doesn't lend itself to me to edge very well, whereas the 19-inch rack platform, which everyone has and has been a standard for a long time, by doing the things, by adding the cages and the really innovative things that Open19 does, solves the problems that we need to solve, but it does it without taking it too far in some ways that the open compute took it. Again, they're two platforms and they are sort of talking together now, but I think Open19, again, really lends itself to that. So what we're doing in our own factory is, as I said, we're deploying the container systems that we would do as a leaf anyway. We're deploying it at our factory with the Open19 inside. And in fact, we are looking to do a pilot for the Open19 Extreme, which Yuval touched on very briefly, which is the liquid cooling version of Open19 as well. Allows us to get some extremely dense loads. At the moment, we're doing 20 kilowatts a rack, but we're seeing some requirements on the high performance computing and other things that need higher cooling requirements. So by going towards some of the technologies of the Open19 Extreme, we can do 40 or 50 kilowatts per rack. So now I can take a container, like a 40-foot container that we have, and I can actually take that up to 400, even possibly 500 kilowatts, so half a megawatt in a 40-foot container. That's the type of densities that we're needing to look at. So it's a very different kettle of fish from co-location, where generally 3 to 5 kilowatts per rack. When you're doing this and machine learning, you're really starting to push the envelope with high performance computing at that 30 or 40 kilowatts per rack. And this is really one of the most simple ways to deploy this. So yeah, we're doing that right now. Autonomous transport vehicles. So again, within our warehousing and factory, we have these little picking robots that run around and do this. And they're running, at the moment, we're doing a pilot on the private 5G as well. So we're doing Open 5G core and coming back to our systems for the control systems as well. I mentioned Fraunhofer before. So we're doing a open manufacturing IT test lab, which is supported by the Fraunhofer as well. So we're creating, as I mentioned, a mesh network with Fraunhofer, putting the on-premises Open19 mesh network, which is, again, using some of the protocols like TSN. New rack production line, so I mentioned our new manufacturing or new production facility. So again, here is, sorry, some of the slide is in German. Still hard to sometimes get some of the slides in English. But you can see some of the technologies that we're using in our stack. So we're using a partner in Germany, IoTOS. But you can see we're using Kafka, we're using Storm, we're using Spark, we're using a whole load of technologies as well to do this. So for me, that's the end of my presentation.